Hey Amy, I need to remove a slug of material from a block of aluminium, but machining it all into chips seems wasteful. I've been reading these brilliant articles about laser ablation and aluminium monoxide vapour absorption with green lasers and...
This is going to be a sketchy quantum setup. I can tell already.
Looks like it's working, but how do I remove the slug?
I found something by Venkman, Stans and Spengler from 1984. They say you mustn't cross the photon beams because it'd cause a total photonic reversal. That would be bad.
I'm fuzzy on the whole good-bad thing. What do you mean bad?
Try to imagine quintillions of atoms stopping instantaneously, causing violent rips in space-time.
Sounds great! Realigning second beam now. What happened to the lights?
Do I look like an electrician?
Well, yes.
Gender expectations, eh? There you go. Hey, careful, that'll be extreme.
Ow!
Lee hot.
You could have warned me.
The first aid kit's in... Oh wait, you used it last time, so I don't need to tell you.
Microwave transmitters generate some unwanted harmonics, so if I transmit on 1.3 GHz, I'll also put out signals on 2.6, 3.9 and 5.2 GHz. To block them, I need to make a low-pass filter. At these frequencies, magical things happen with very simple geometries. The filters I'm making consist of an aluminium block with a machined bore. Classical low-pass filters use a set of inductors connected in series with capacitors to ground. At microwave frequencies, a thin rod in a tube looks like an inductor and a fat rod in a tube looks like a capacitor. So we can use the normal Chebyshev design approach to get the values for the inductors and capacitors, but just use rods of the right sizes inside a tube. There are end effects and fringing fields to deal with, but luckily Dominique F1FRV came up with a brilliant Excel sheet that does all the corrections. So all a humble microwave machinist has to do is make some discs of precise diameter and thickness, solder them to a rod of a suitable size, bore out a hole so there's a bit of an air gap, fit some lossless spacers and attach sockets to the ends. Being of a somewhat nervous disposition, I put the dimensions into a Fusion 360 CAD model so I could check everything fitted and looked right. Also, it looks swoopy and cool and spits out dimension drawings for those of us not blessed with a Haas CNC machine. I need one of those Lego cranes that Adam Booth uses. It'd be brilliant. Amy, I know for a fact that your voice synth is unable to snigger, so don't even try. These camlock chucks are a bit of a faff to change over, but they're very repeatable and they allow full power in reverse, which is nice. One of us forgot to order some 30mm brass bar for this job, so I'm having to waste some bigger stuff. A new bar of the right stuff will be here in 3 days. Perhaps. It's probably not that important to get this bar centred up, but it's a big lump to have wobbling around, and I need the 4-jaw alignment practice in case I ever make it to the Bar Z bash. Collets are just too easy. Those ER40s are a gateway drug. I'm going to end up as a 5C user skulking on street corners trying to score some rubber flex. My name's Neil and I'm addicted to collets, but I can handle it. I think that'll do. In funny money, that's about 5/10, which any number theorist knows is a half of something. For those of a more metric persuasion, it's 100 microns. Force of habit means I inspect my inserts with a jeweller's loupe before committing violence against metal. This one was janky as a janky thing, so I flipped it to give me a fighting chance of a decent finish. Talk about living life close to the edge. That's me breaking one of my cardinal rules and removing the insert screw over the chip tray instead of my usual nice safe magnetic bowl. Shop looks more like a flipping film studio every day, nowhere to move.
Hey Neil, can I say? First we face off the workpiece, as is tradition.
No. These YG1 aluminium high rake positive uncoated inserts that I get from Cutwell work splendidly for finishing brass, but they leave a rotten finish when you take more of a cut. However, the chips are chips and not powder that sprays everywhere, so I can put up with it. Right, that's nicely on dimension for the diameter. Now I need to make the 3mm bore. Starting with a centre drill, then a 2.75mm cobalt jobber, and finish with a 3mm straight flute reamer. This 3mm reamer's nothing special, it came in one of the better Chinese kits. I need a small countersink on one face of each disc for the solder to form a good fillet and get sucked into the joint by gravity and capillary action. But the hole's tiny, so I'm using a 6mm carbide spotting drill. Works a treat. I'm only de-ragging the edge, just a faint dusting to remove any sharp edges or whiskers. Then it's parting time. Sliding a straight edge across the face of the workpiece, I fiddle with the carriage position until there's an imperceptible click as the edge touches the tip of the insert. A quick clean-up pass and we're ready to make the next disc. The drill and reamer aren't exactly the longest in the world, so I'll have to re-drill and re-ream the hole a bit. Is re-ream a word? Well, it is now. Oxford English Dictionary, please take note. You heard it here first. Rather than wasting any more of this oversized bar, I'm going to use the 8 discs from this batch to make the first 2 filters. The discs need to be cut to different, very precise thicknesses. I'm going to use a superglue chuck approach, fixing the machined face of each disc to the machined surface of the stock in the chuck. Rather than trying to clean off the chuck between uses, I'll just take a 0.1mm skim cut to clean the surface. First steps to clean the discs and chuck face with acetone, then apply a few dabs of high viscosity cyanoacrylate superglue and stick the disc to the chuck. Someone's going to be thinking, how does he know how thick the glue line is? Well, dear reader, I measured him, it. I faced the glue chuck and zeroed the DRO, then stuck an oversized disc to the chuck, machined it to 6.00mm, then removed it from the chuck, made sure it was clean, measured it with my best micrometer. Repeated that 3 times, each time 0.5mm less, because I'm like that. The average size of the disc was 22 micrometers less than the DRO measured offset. I tried to use roughly the same amount of glue and pressure each time. One day I'll find that fancy CA glue that contains glass microspheres that give a precision bond line thickness. Time for some propane nightmares then. CA glue melts at less than 200 C and leaves the workpiece totally clean. All the residue stays on the chuck. Most convenient. Offsetting the tool 22 micrometers more than the specified thickness resulted in finished discs within the permitted tolerance. Sort of, it'll do, rather than huzzah for precision. In this universe, we obey the laws of physics, so it's back to life, back to reality, to see how the aluminium block was bored without the use of magic or intercessions addressed to the things from the dungeon dimensions. It's going to be important to get the central hold aligned as closely as possible with the outside of the workpiece to make milling the body to the finished size a bit simpler. I'll still need to use that plug that was ejected by ghostly fluences and magical photons as an alignment aid, but the bore should be reasonably parallel to the unmachined faces, so I can simply clamp the thing in the vise on wide parallels and mill the sides and top after centering the spindle on the plug axis. Setting up square-ish stock in the forward jaws a bit more fiddly than with round stock. I don't have a really long stroke dial gauge, so I have to move it to the end of the workpiece after every measurement. It's kind of relaxing in a sort of ASMR segment way. I promised Amy I wouldn't do that spooky whispering thing again, so kick back, open the popcorn and crack a tinny, whatever that means, as I fumble this to the point of being good enough for government work. And exhale. Nearly nodded off again there. I'll square up the end of the block to give me a reference surface to work from. I'm using this huge centre drill because it looks comedically large and makes me ridiculously cheerful. With the current state of the world, that's pretty impressive for a pointy lump of machined steel. The finished size of the hole in the end of the block needs to form a 50 ohm coaxial transmission line with the extended end of the central copper rod and the solder spill. There's a logarithmic relationship between the surge impedance and the ratio of the inner and outer diameters. It turns out the hole needs to be 7.1mm. I'm using a long series 6mm HSS Cobalt drill that I bought from Drill Service of Hawley. It's not quite long enough to do the full depth, so I have to resort to some sketchy chucking later on. If that sort of thing gives you dyspepsia, you should probably avert your eyes. Oh, the horror.
Neil, that was a bit silly, wasn't it?
Way ahead of you for once, Amy. The finished internal diameter is 30mm. This is a 5/8 UNF tap drill, 37/64, around 14.6mm. It's long enough, but of course the tailstock quill travel's 20mm too short, so I'll have to take special measures. Once again I'm using the cheap 3mm gauge block to set a reference position for the tool so I can measure the depth of the hole using my tailstock DRO. I zero the DRO scale with the block in place, then because I'm a bear of very little brain, I move in 3mm and zero it again so the tip of the tool's flush with my reference surface and I don't have to suffer my ultimate nemesis, mental subtraction. At this point I put the gauge block in again and measured the distance from the workpiece reference face to the edge of the taper on the chuck. Exactly 150mm. Convenient. Could have been planned.
Planned, lol, never.
It would be a huge help to me if you felt able to click the like button so the algorithm will think this nonsense should be imposed on even more of you lovely people of the internet. I set the offset to 75mm and zeroed the DRO with the tailstock quill fully retracted and drilled the hole to depth. Next on stage is the 1-inch blacksmith's drill. It's way too short to reach the bottom of the hole, but it's good for hogging out material in preparation for the big drill. This is a Morse taper 3" and 1/8 drill. The quill's just long enough to drill this internal hole to full depth. I treated myself to another boring bar that takes CCGT inserts for doing aluminium. Using a ruler balanced on the flat on top of the boring bar to align it with the holder is a bit rubbish, but it seems to work. This tool height setter was the first thing I ever made in this machine shop. It's a terrible camera angle, but I'm just checking that the bar's parallel with the lathe axis. quick check of the bore dimensions so I can set the DRO. This SPI bore mic isn't bad at all. Hey up, that's near as damn it. There is a bit of taper on the bore, maybe about 10 microns down the whole length. I can't use a small boring bar to face the bottom of the hole, so I'm using a 20mm end mill and an ER40 collet to cut the centre section to length. Then I'll use a medium boring bar to finish the rest. Collets. Ooh. I can stop any time, right? The bottom of the cavity should be fairly flat now, apart from the central section, which was under the slightly hollow cutting surface of the end mill. The depth mic seems to agree and confirms that I'm within a very thin part of a proverbially thin thing of the desired depth.
That looks almost acceptable. Just about. Maybe. Perhaps.
High praise indeed. Bob Corley taught me how to use two dead centres to check the alignment of a hole in the end of a workpiece in the long hot summer of '76. Different century, different world. Or was it? Same old fuel crisis, wars, threat of nuclear Armageddon, and me mucking about on a lathe.
Plus ça change, plus c'est la même chose.
Although the alignment of the hole is reasonably good, I'm using a very stiff 6.75mm stub drill to open up the hole before drilling it to the finished size with a jobber. Next on the agenda is to face off the end close to dimension, then measure it with a depth mic. Actually, I use the DRO as well, but hey, the traditional ways are reliable and gorgeously tactile. The length looks good, although the controlling dimension's actually the depth of the board cavity. I'll adjust the step height on the end cap when I make it just to be sure the cavity length is within tolerance. Next step's to mill the body, drill and tap the socket and cap holes and make the access person hole for soldering, plus make the end cap and adapter pins to connect the copper tube to the end sockets. All of that's in the next episode, which will appear up there when I get it made. If you made it this far, that like button might look eminently clickable, and perhaps even subscribe. Thanks so much for tagging along as I fumble my way to microwave nirvana.